Hello, everyone. I'm your host, Daniel Litwin, the voice of B2B, and welcome to another episode of Wavelengths, an Amphenol broadband solutions podcast. Again, I'm your host, Daniel Litwin, and thank you so much for joining us on another episode of Amphenol's show. As we explore today's industry thought leadership, make sure that you're subscribing to our podcast on Apple Podcasts and Spotify. Once you do, you'll have a full catalog of previous conversations, plus notifications when we drop new ones. And you're also going to want to go to our website, amphenolbroadband.com. Again, Amphenol, A-M-P-H-E-N-O-L, broadband.com. For more information on the various technologies we're going to break down today, but more importantly, some Amphenol content, including episodes of the show, videos, articles, and more. So, for today's conversation of the show, we're going to be discussing some timely updates as well as challenges to realizing the autonomous vehicle dream. And that dream is hitting level 5 advanced driver assistance and basically full autonomy. The ever elusive higher levels of automation have made commercial production and adoption of fully autonomous driving systems a work in progress as companies test and explore various cutting-edge technologies to achieve that autonomous dream, such as sensor systems, AI-enabled processing power, etc., to reach that mass production and universal adoption goal. Till we see level 5, though, it appears that we're going to be stuck around level 2 autonomy for the short term, with level 3s close to success and levels 4 and 5 still prototyping for the most part for mass production. So with our conversation today, what we're wanting to do is break down what that journey to level 3, which is that next tangible goal in the broader automation goal, what it's going to take to get there, what are the steps that are still missing, what is already moving in the right direction. And we're going to be adding a B2B spin by really focusing on the business relationships, the market movement, and technology investments that are necessary to move that automation mantle forward. So, here to give us insights today on the program, we're joined by Hans-Ulrich Mueller. He's Group Technology Manager for Amphenol Automotive Products Group. Mr. Mueller, great to have you on. How you doing?
Thank you so much, Daniel. I'm doing great. Hello to the wonderful Texas and the US from Germany. I'm looking forward to give some insights from the Automotive Products Group on autonomous driving.
Yeah, well, it's great to have you on the program, and, we'll give Germany a little Euro Cup shout. They just crushed Portugal the other day, and what an incredible showing. So great to have you joining us, yes, here in Dallas, Texas, a little crossover episode. But we've got a lot to unpack. I would love to learn more about your perspective here. So actually, to start, do you mind giving our audience just a quick elevator pitch, a little 30-second rundown on your background in this space and why you have some authority to speak to the broader transition to autonomous vehicles?
Yeah, I started as a mechanical engineer, graduated back in 1990 at a university in Stuttgart. And I started my career first in relay and connector design and manufacturing. And I turned in the mid-90s to the auto industry and started in 1999 at Amphenol, one side of the Amphenol, as a design engineer and leader of R&D manager. Back in 2009, firstly we worked mainly with safety systems, airbag, SRS systems, connectors. So in the passive safety, as well as in high power electrification. At this time, no e-mobility, but in the meantime, we have a lot of e-mobility products and the safety and communication products. In 2009, the Automotive Products Group was founded or formed inside the Amphenol Corporation. And since that time, we were growing into different technology segments. And since that time, I work here as a technology manager, supporting the new technologies, new areas of all our divisions in the automotive arena. And of course, the major trends in automotive is electrified driving, autonomous driving, shared mobility. These are the main drivers, and of course, the combination of autonomous driving and e-mobility is one of our major areas. And I worked with different companies in several years on these technologies. And yeah, we have a lot of experience and components supporting this industrial. It's not a disruption, it's an evolution.
And that's exactly what we're going to dig into today. Thank you for that context. What I want to do now is really discuss that evolution and break down why the transition from level 2 to level 3 and onward really does look like adding on top of existing winning technologies and methodologies, but also try to draw some distinctions between what technologies and strategies for reaching level 3 and beyond have we not employed at scale yet that we should be, and why. So what I want to do is give our audience another little elevator pitch recap, but this time, just in case we have listeners who aren't familiar or need a refresher on the levels of autonomy, can you go down the line real quick and give us that redefined update, basically how the industry is defining each of those levels from level 0, which is no autonomy, to level 5, which is full autonomy. Where does each one of those regions land on the list, and what does it encompass today?
Yeah, of course. There is a good definition of the SAE about the 6 levels. As you already mentioned, level 0 is nothing inside the car. So the human driver need to do everything. He is the sensor. The sensor is basically the eye. He is the actuator, steering and braking with the arm and the leg. So everything is, let's say, pure mechanical and controlled by the human. Then it starts with level 1, level 2. These are the first initial sets with sensors or with systems that assist the driver. It starts really with a control of steering, of the brake, of the speeding, speed control. This is typically in level 1. Level 2, it is going to be a little more smart. You have let's say, adaptive cruise control, where you really can set up also basic or easy functions like the distance to the vehicle in front of you, so that the speed is reduced and picking up. This is more or less level 1 and level 2. These are the typical systems that are inside every vehicle. In the meantime, level 2 a little more advanced, but this is standard basic technology. When it comes then to level 3, the system can take over the responsibility for the driving for a certain time. This means cars with level 3 are already equipped with a complete system that enables the vehicle to drive autonomously, which means all functions that are usually controlled by the human driver, like steering, braking, lane control, and so on, have to be electrical or has to be automated in the system. Typically, it's electric. And then for a certain time, level 3 really allows that the vehicle is driving completely by its own. It's a couple seconds, 30 seconds, 1 minute, whatever. It really depends on the vehicle. But after this time, at least the vehicle is giving a signal so that you take back control. I have a Mercedes. There is a red sign then coming, telling take over the handle and grab your steering wheel again. Otherwise, after 1 minute, the car will go into a stop situation and reduce the speed and come to a complete stop. This is level 3. This is technically at the moment, let's say, the accessible or good state of the art, what is integrated, especially in premium vehicles. And then it goes to, but the system is really set up that the driver has to take over the control of the vehicle in a certain time. Then it comes to and this is also called highly automated or automated driving. Then it comes to level 4 and 5. And these are both levels that are fully automated, fully autonomous. The car is able to go from point A to point B without any interaction, at least in theory. A difference between level 4 and 5 is that in level 4, this is still a classic vehicle or a car that we are used to. So you have a driver's side, you have a driver's seat, you have a steering wheel, you have the pedals for the control. Everything is inside the vehicle, but it's not needed in theory, or at least if you go autonomous, you don't need it. And if you talk about level 5, same functions inside, but there is no steering wheel, there is no seat for a driver. It is fully autonomous. It goes fully by itself. No control of a driver. There is actually practically no driver inside. It's only passengers, no drivers. If you look into the system itself, it has to do a lot with responsibility. Who takes the responsibility in the vehicle? And going up to level 4, the driver is responsible. And at the level 5, this is there is no driver, so there is no responsibility at the driver. So this question is still challenging in some areas. But then really the owner or the fleet person need to take the responsibility. And this is basically the level 0 to 5. At the moment, the industry is in the area mainly between 2, some vehicles at 3, and some pilot cars are already able to run 4, but in a very experimental status.
Right. Yeah, that higher autonomy is definitely still in the prototype era, the beta testing era. But, from what you're describing, it sounds like level 3 is maybe a little closer than it sounds, at least mass production. So that's what we'll dig into here. You brought it up earlier. You've been a leader in the industry for years now. Over those years, obviously, autonomous vehicles have gained more clout, but more importantly, more visibility, and the achievability of reaching autonomous vehicles at scale has felt more in our grasp. So I'm curious, how have you seen the conversation around what is and isn't achievable for autonomous vehicle solutions evolve during your industry tenure? Because to your point, the broader push for autonomy, it is an evolution, and obviously the conversations around that have changed and evolved as well. So go ahead and break down how you've seen that public conversation, specifically from industry professionals, also change since you've been in the industry.
There is of course a change, and we have to look into the system, autonomous vehicle system. If we are talking about autonomous vehicles, everyone thinks about a passenger car that is running on the road and that is just going independently without a driver. But this is not the market and the whole market for autonomous vehicles. Just think about all the other possibilities for autonomous driving and vehicles, starting with delivery trucks, robotaxis, where you have services to deliver goods or individuals to bring it from A to B. But it's also going into agriculture, where you have automated farming, where you have in a factory transportation. There is a lot of autonomous driving already there, where you have limited tasks, limited duties, and it's a limited area. And you see a lot of autonomy really running there already. Also, if you look into the aircraft industry, autopilot in the aircraft is a standard feature since a lot of years, and the aircraft is driving by itself over the Atlantic Ocean, no interaction of the pilot needed. So it's not really new. What is the challenge when it comes to vehicle is really the reaction time or the time that is needed to transfer a vehicle in drive mode or driving vehicle into a safe condition. And if you just look into an airplane, if there is any error or whatever, you have minutes until you reach a critical situation, usually minutes until you reach a critical situation And if you just think on a vehicle that is driving in a suburban area, children are there on the street playing whatever with a bicycle or with a ball or whatever, you have milliseconds to react and to bring the vehicle into a safe state. And that's I think the biggest difference. To come from an instable situation into a stable situation, and that's in the autonomous driving of a vehicle, really the highest demand to have this in a very, very short time. And then we have also on the other side the expectation. If you talk about autonomous vehicles, everybody thinks then really, or a lot of people think autonomous is everything is autonomous. But I think it will happen in steps. If today I really can think easy or the system is easy for an autonomous highway driving or highway assistance, so that you enter the highway, have couple hundred miles to drive, and the system is really able to handle this without any issues. You have not so critical interactions with unforeseen obstacles or events that happen in an urban situation or surrounding from time to time. And it will take. This will come soon, I guess, sooner than fully autonomous, where you have also a vehicle in suburban areas or metropole areas, or even off-road. Think about the big areas in the north or northeast or whatever. It's really northwest. It's really wide territory, and it will take a longer time until you have all the data there available. That is enabling you to drive there autonomous. So we have to look into different sections there. What will influence this the autonomous driving itself?
So right now, what we see being mass produced is max around level 2. You said we've got some kind of pro level cars, some more luxury level cars today that do offer level 3, and then prototyping around level 4. So how are industry professionals today treating that transition from level 2 to level 3 at scale? What is being seen as achievable? What is being treated as a roadblock that is inhibiting that scale from 2 to 3? Go ahead and give us some insight into how professionals are maneuvering this challenge today and why.
Yeah, maybe we have to give a little excursus into the technical system of autonomous vehicle. What is needed? So first of all, autonomous vehicle is acting like everybody has three levels: to see, to think, and to act. To see, the vehicle needs information, and information is coming from different sensors, cameras, radar, lidar, in front of the vehicle, from the outside, from the back, from whatever direction. But information comes also via the cloud, and this is one of the topics of today's discussion as well. 5G as an enabler of data. So you need precise data about your environment that you are in. Map data, high resolution map data. What is in the traffic conditions, if there is a construction area and whatever, and communication vehicle to vehicle. What is there around the corner? A best sensor system in a vehicle can be only as good as the human eye, because you can't look around the corner. Looking around the corner you can only do with connectivity, and therefore you need real-time data, and communicate it to a vehicle. So this is the portion to see, to really see everything which is around the corner. And then you need to think. For thinking, you need a lot of software, a lot of information, a lot of algorithm to really detect and predict what is the current or describe the current situation and predict what is next. And then, of course, you have to have the action, the act. And therefore, you have to have the electrified system in the vehicle, to have automatic steering, automatic braking, acceleration, the powertrain, the chassis system, And of course, you need also to interact to control everything or to maneuver everything. So you need an advanced HMI system. Very often, it's voice controlled to interact with the vehicle in a way which makes it possible. So this see, think, act is the chain of commands that is needed. If you look into level 2 has advanced sensors to see. But it's not to see around a corner, and it's not to see and get the information over the cloud or over the 5G services. It's only to see what is there, and this is possible with a reasonable complexity, and complexity means there also a reasonable cost. When it comes then to level 3, you need to have then also the electric or the automated actuator, steering, braking, acceleration, powertrain, whatever. So you need another level of information. And when it comes to the level 3 driving autonomously, you need also to have there much more computing power and power really to calculate everything. And this is basically a cost factor. It's not a technical factor right now, it's a cost factor. And if you really look into the add-on is the same, regardless if it's a basic car, a small car, or a premium car in the premium segment. And that's why really it's mainly at the moment used in premium cars, because the add-on is percentage-wise, or the add-on itself is not that significant as at a small car. And that's, I think, the reason why most new technology and innovation is first introduced in the premium car segments. Mercedes S-Class is one of the technology, or BMW 7 Series are the areas where new technologies are usually introduced first, and then it goes down to mid-sized cars and then to the mass cars. And this happened with all innovation, all significant innovation, like the airbag system. The moment when it comes really to the premium, from the premium to the midsize and to the basic cars, the volume really exploded. I just can tell you, in the time when I started, 1995, with the industry, this was really the time where you come from 10 million to 100 million to 1 billion, really in a very short period of time, applications per vehicle. So this is really at the moment on a level cost-wise, the add-on, which is, or the complexity, which is eaten up in the premium segment. The moment when it comes really it becomes available at the higher volume, economy of scale, then I think it's step by step. It will come also to the next level of vehicles, and you will see this transition going on in the next years, from level 2 to level 3, and probably then also level 4. But mainly 3 is in the next 4 to 5 years development, which is going on.
So for those core technologies then that are basically essential for enabling the thinking and the acting side of autonomy, or at least raising their capacity, what is holding that technology back right now from achieving level 3 at a sort of mass consumer production scale, and why?
I think the systems are available, but at the moment at a certain cost, and that's really, again, it comes to that point. And you can't really put them into systems where you have really. Yeah, if you look into a camera or in a front system that you have in the front of the car, you have a radar, LiDAR, ultrasonic sensors. You have cameras, 3D cameras. This is one side, and then you also need to cluster all the information to make a virtual picture of the scenery around your vehicle and in front of your vehicle. This is really with a high density. Is there needed? You need to detect the obstacles or the things, the objects, and then define what might be the strategy or the movement, the change of the movement of this object. to see the difference between a child in a 100 yards distance and a dustbin. This is not so easy. And then also see, has the children a ball? Is the ball falling down? Is it running towards the street? Is it moving in the other direction? This all need to be detected and described and predicted then what is the right strategy for the next move. So and coming back to what is the what will be the enabler from level 2 to level 3? I think it's the economy of scale, maybe with new generations of, or for sure, new generations of sensors, of combined systems, where you have then a better chance to really generate the complete model of your surrounding. So the sensor cluster, this will help a lot. And this is one of the main focus areas in the future for soft and hardware, really to bring this to a next level, to bring the cost down for the system needed in level 3 and level 4.
And real quick, before we look at the bigger picture here and I introduce some other context, ABS and Amphenol Corporation, which is a sort of broader Amphenol Broadband Solutions parent company and project. I know y'all manufacture several core components for the autonomous vehicle ecosystem, everything from engines to switchers and sensors, and that really is a summarized list. So what I'd like to ask is, where does ABS's technology portfolio fit into this ecosystem, and how do you see some of the solutions that Amphenol is creating enable this transition from level 2 to level 3? Basically, what role does ABS and Amphenol play in achieving that transition from level 2 to level 3?
All the systems that are in the vehicle require a high communication and data traffic in the vehicle and also to the outside, to the infrastructure, to vehicle, wherever. So it starts, when we're talking about the vehicle, it starts with the antenna system communicating with 5G, but also other frequency bands. The communication to the outside. And Amphenol is supporting both sides, one on the infrastructure side with our antennas, with our broadband solutions, with the connectivity and the wiring and the systems that enable the infrastructure to have this grid and this array of network. But then it comes to the vehicle, then you have this antenna, the 5G antenna, and very often you have much more antennas than one in the vehicle. In the vehicle, we are talking in the meantime about 20 antennas for the different frequencies and bands. And the higher it goes, the more you have to look into the losses that are there and connect then the antenna with the receiver and with the receiver inside the vehicle, the network. You need to connect it to the server, to the domain controllers, and then down to all the controller levels that control and enable the communication with all the different systems, the sensors and the actuators. And this is where our main focus is there, from the antenna to the wiring, from the wiring to the inside the board or I/O ports in the electronics, inside the electronics, the board-to-board connections, the high-speed backplanes, everything there. But then it comes also to the actuator, the system. So everywhere you find components and systems that are developed and designed by Amphenol. We work there very close with our customers, with the OEMs, with the vehicle manufacturers, but also the successful tier ones who do the systems, and that's the area where we are. And if you think about autonomous driving, it's even more that is needed than just the systems. For example, we have a washer fluid control system, which is considered as a part of the ADAS or autonomous driving system, to control the fuel level, the washer fluid that washes the camera in case of dirt. So this is considered as a system that is needed because you have to make sure that in every case your camera system has an optimal view for the front in front of the vehicle. So if there is a dirt, you need to wash it away. And to wash it away, you need the washer fluid. And that's just the simple things that are needed. And we as Amphenol support all these areas and arenas. And have the clear focus to have a high reliable system in the vehicle that is enabling autonomous vehicle technology.
Hans, thank you so much for your insights so far. What I want to do now is try to get a little more granular with some of the dynamics beyond technology and beyond cost that are also shaping the rollout to level 3. So first, I want to chat how the OEMs play into this discussion. So as the industry seeks to reach level 3, it means that there's a convergence of OEMs, contract manufacturers, suppliers, software developers, et cetera, basically several different industry players and even beyond that, different verticals coming together and collaborating to discover that right path to level 3. And that means that they need to find a path that is economical and obviously, fruitful for the vested interests, but also a path that is beneficial for the end users and for the environment as well, which seems to be a leading metric in these discussions. So, in your opinion, how should these disparate players across the industry organize some of their innovative responsibilities so that they can work efficiently to achieve level 3? Basically, across that autonomous vehicle supply chain, who should take on the burden of fixing this issue, solving this challenge, or discovering this direction, et cetera, for getting from level 2 to level 3? How do you see that division of broader labor playing out? Or how should it play out, in your opinion?
I would honestly not say it from level 2 to level 3, because level 2 to level 3 is just adding the existing systems. It's going toward level 4 and 5. This is the important area where a lot of this contributing factors need to be solved and need to reach the next level. And this is mainly also with the with corporations with these different stakeholders and supporters of this industry or enablers of this industry. First of all, it is needed to have a real good concept on safety, reliability, and therefore you need to do a lot of testing, a lot of simulation, and prove that the technology is reliable, is safe. Because one of the biggest roadblocks right now is for sure the acceptance of the people. Technically, it is working. The vehicle is always acting in the same way. It has its algorithm. It has its standard. It will never be tired. It will never be disrupted with any influences from the outside. It's just always available. 24/7 it's running. But it is a technical system, and a technical system has also some failures, some fail rates. You need to make it as safe as possible. And safety and security, also cybersecurity, is one of the big challenges where all the different industries need to work together. How to protect the vehicle, the driver, or the passengers inside, and protect the environment. Of course, a vehicle is also in a very harsh environment, so it has to be very robust. If you think about a vehicle on the road in the winter, you have every day from minus to plus in centigrades, but from 0 to a lot in Fahrenheit. You need to have their really very robust systems. You have to fulfill the functional safety requirements. Very often you need redundant systems. If you think about the essential functions in the driving, if you have one error in one central computing unit, immediately in less than milliseconds, you have to kick in the basic functions with a redundant system and take over the control. to bring the car again into a safe status. And all this require a lot of innovation and cooperation to really have the technical reliable system, to have also acceptance level of the people using highly automated or autonomous driving. And of course, it has also to be what needs to be solved is the liability case. Up to now, the driver is always liable for a car, and this goes back to the 60s, where the Vienna Convention told that or defined that the driver is always liable and responsible for the vehicle. But what if you don't have a driver anymore, or not, at least not a driver in service? So all these things need to be also addressed. Liability, responsibility, moral is a big point that require also a discussion or political discussion. There is always in the discussion something about these dilemma situations. What happens if you have a situation where you can only take one of two decisions both are bad or both are wrong, but who takes it? A driver is a human driver is taking the decision by intuitive decision. A system, autonomous driving system, must have there an algorithm, a line in the program that says A or B, and this is a very critical point. Who decides what is more important? A pregnant woman or a group of children? What is more important? And this is a question that could not be answered. It is just one of the big challenges that are there. These dilemma situations and dilemma decisions to do it not with an intuitive decision, but with a programmed decision. And these are a lot of things that are that need to happen in parallel. To have the technical system, to have the legal aspects and the moral aspects, and safety, security, to bring this all to one consensus. And this will take several years now until we really see there significant progress and a significant number of autonomous vehicles on our road.
All right, Hans, thanks for the insights again there. What I want to do now is pull from your German background a little bit. Since you are a German guest here for us, I want to highlight what the government of Germany has been doing as of late to build a framework for mass AV adoption and use that as a bouncing off point for understanding, does this set the bar in any ways for global transitions from level 2 to level 3? Basically, they recently rolled out some regulation and policy for at-scale level 3 autonomy and how to achieve it, as well as some of the metrics that need to be decided. Their legal framework is still in its infancy, but these AV regulations passed in late May and now basically have federated guidelines, including procedures for getting an AV operation license, for example, or regulating data processing and type approval for autonomous vehicles, et cetera, et cetera. So could you give us some more context on this? And how does this regulatory framework impact the rest of the world's push toward level 3 and above at scale? Does it set any new important bars that you think are positive, or is there anywhere that you see room for improvement that we should also be talking about?
Yeah, we talked before about the different aspects that need to be solved, and the legal aspect and the framework for the industry that is involved in the development of the different technical systems or ecosystems is an important step forward. So the German government really brought this new regulation in May, decided in May. And this gives all the stakeholders in the autonomous driving industry a better basis for the strategy, for the risk assessment, and for to define their roadmaps, how to move ahead and to go ahead. But you have to see what is exactly inside. You already mentioned this. This is it's defining the conditions, how how a vehicle, our autonomous vehicle, self-driving vehicle, acts on the public road traffic, and it does a regular regulation and gives some guidelines. It regulates, among other things, the obligation of the vehicle owner and the manufacturer, as well as the technical supervision, which steers and controls the vehicle itself. But it's not a distance from, but not at a distance, but everything that is inside or onside the vehicle. And this steering comes from an autonomous vehicle. Everything that comes from the autonomous vehicle function itself in the vehicle. And this is, giving also the framework, or giving the framework with an open system. And there's the so-called dual mode systems or vehicles that are already equipped with all the technical content to enable level 3 or level 4. And that just have then the upgrade possibility to run level 4. This is just giving the framework of all the regulations. I think it's an important step, especially also for Germany, who has this innovative leading position in the autonomous or in the automotive market or area. But it's in the meantime not only Germany or Europe. All these customer or suppliers, they act globally, and even if the supplier is considered as a German corporation, a lot of the development is done in the Silicon Valley, everywhere in the world. So it's a global system. But one of the key factors for the German industry is really to stay ahead or stay really on top of this vehicle autonomous technology. It's one of the remaining areas where the German industry is somehow in a leading position.
There's some other big news I want to highlight here, and that's coming out of GM. The auto manufacturer announced recently it's now planning on spending around $35 billion on boosting both its electric vehicle and its autonomous vehicle investments, just signaling that this is becoming a priority for some of the leading auto manufacturers across the broader vehicle supply chain. So I'm wondering, where should that money be going if GM wants to get level 3 and above off the ground? For example, let's say GM launches the first level 3 mass-produced at-scale consumer vehicle. Where should they be investing their money now to realize that vision, and why?
Yeah, first of all, it's a combined investment in EV and AV. So I think one big portion will be consumed by the electric vehicle electrification. And here the biggest challenge is really to bring the cost to an acceptable level, and to work on the battery density, to have there an acceptable range, charging, everything which is linked to the EV. So this is one significant area. And then for AV or for autonomous driving, of course, it's the integration or the further development of the hardware that is needed on a sensor, on an actuator level, to integrate that on a acceptable complexity in the vehicle. And then when it comes to level 3 and above, also very important is the software and hardware development, all the algorithms that are in the vehicle, to take the right decision, to consider all the situation, to detect and to have the surrounding of the vehicle in a model. So there's a lot of software development needed. It also needs artificial intelligence. You need to really bring down to calculate or to see all the data that are created in the vehicle or communicated to a vehicle, really focus on the significant data You have to do a pattern recognition, what is significant and what is not significant, and bring all this level into a clear decision matrix. And I think this is an area where a lot of investment is needed, or a lot of our R&D is needed, really to bring this artificial intelligence and the software and hardware in the vehicle to the next level. Hardware development is happening in parallel with the development, or with the increase of computing power. With the Moore's law, this is still valid. This is helping all this industry and these technologies a lot. Systems are available, are functional now, but absolutely not acceptable for a user. With safety first, the car would stop every other second because it has to recalculate and rethink the situation and then move the next step. These developments need to go in parallel, and R&D is mainly needed in software and hardware development and electrifying the complete drivetrain.
All right, Hans, last question for you. But in summary, what are the most actionable steps that the industry at large should be prioritizing to put level 3 autonomy on roads everywhere, right? Because it seems like there's a lot of moving pieces, and you brought it up yourself. This needs to be sort of a coordinated mass investment across various parties. So, as I ask this question, I know there's not just going to be one sort of magic wave your wand answer, but should we be focusing more on regulatory movement? Should this be something that is an investment into already existing technologies, but just boosting their capacity or boosting the cost it takes to produce these at scale? Is this an issue where we need to be innovating around newer technologies that have yet to see scaled production? Basically, weigh some of those various moving pieces. How should we be prioritizing them, and draw some connections between level 2 and level 3? Again, just sort of in summary to wrap us up here.
I think you can't really prioritize only one of these important elements of the whole infrastructure that is needed. It has to run all in parallel. Very important is the communication, the cooperation, and collaboration in the different disciplines. We have with autonomous driving also the special situation that we have, in some areas, a change of paradigms. If you look into the auto industry is, to say, very conservative. You have a product lifetime, usually from the development until the vehicle is no longer there. It's 6, 7, 8, maybe 10 years. And the development time before you launch a vehicle is typically 2 to 3 years. If you just think on the other technology field, which is very important, like mobile devices, your cell phone, your communication devices, you have a product lifetime which is probably half a year, and then you have the next generation, which is creating a lot of expectation for the system. So a vehicle needs to really, or we have there two worlds that are coming together. We have on one side the very conservative automobile industry. They are really focused on a long lifetime. A vehicle must run 10, 15 years, high reliable. It is a costly device, so you don't throw it away after 2 or 3 years if it's not running. It has a really harsh and critical environment. And on the other side, the people are expecting their system that has the latest and greatest possibility that you see in all the apps that you have in your private mobile device. And to bring really both worlds together, this is one of the biggest challenges that I see. Companies or corporations like Amphenol is really there on a very good position, because we know both worlds. We know the automotive world, and we know the world of mobile communication and mobile networks, the networking. But this also needs to happen with the automaker, and this is also something you see more and more. That big IT giants are working with the automobile industry. So there are several announcements out there with whom Apple will make his first car. you have Google, who is cooperating with a lot of or is in discussion with a lot of OEMs. There are new partnerships, new alliances there. So you see it more and more that really these industries are having a merging situation, come together. And I think this is one of the biggest important enablers for autonomous driving and for highly automated driving, and that the different industries are coming together, and we take the best of all industries and make a reliable and a safe autonomous infrastructure.
And I think on that note, Hans-Ulrich Mueller, we'll go ahead and wrap up our conversation today. So thank you so much for joining us on this episode of Wavelengths and breaking down some of the challenges as well as the coordinated opportunities for transitioning from level 2 to level 3 autonomy at scale. Again, we've been chatting with Hans-Ulrich Mueller, Group Technology Manager for Amphenol Automotive Products Group. Mr. Mueller, if folks want to find out a little bit more about some of your work in this space, they want to follow along with your thought leadership and research, or maybe they just want to learn more about where ABS fits into this broader transition, how can they learn more, or how can they get in touch?
Yeah, of course, we are available globally to support all our customers and who are interested. We have this website that you just mentioned, also amphenol.com. Or Amphenol-automotive.de. So these are all the websites where you can find us. We are available to support you and the industry.
Perfect. Hans-Ulrich Mueller, thank you again. We'll chat again soon.
Thank you. Have a great day.
And thank you everyone for watching another episode of Wavelengths, an Amphenol Broadband Solutions podcast. If you like what you heard and saw and want some previous episodes, or you don't want to miss out on any future conversations, make sure that you're subscribing to Apple Podcasts and Spotify, where you'll find more episodes of Wavelengths in audio form. If you want to see all the videos, make sure that you're heading to our website, amphenolbroadband.com. Again, amphenolbroadband.com. I'm your host, Daniel Litwin, the voice of B2B, and we'll catch you on the next episode of Wavelengths.